Hello, my dear students. In the previous session, we had discussed about the introduction about acids, bases, and indicators. Today, we are going to discuss the important topic of this chapter, that is chemical properties of acids and bases. Let's get started. The first chemical property we are going to study is reaction of acids and bases with metals. How do acids and bases react with metals? So let us see the reaction of metals with acids. When metals react with acids, there is a formation of salt and hydrogen gas. In general, we can write metals react with dilute acid to form salt and hydrogen gas. Let us see the different examples here. Let's take zinc as an example. Zinc is a metal. When it is made to react with dilute HCl, that is hydrochloric acid, it is solid, aqueous. There is a formation of salt, zinc chloride, and there is evolution of hydrogen gas here. See, zinc being more reactive than hydrogen, it will displace hydrogen from this dilute acid to form zinc chloride, and there is evolution of hydrogen gas here. We have to balance the chemical equation here. Two chlorine atoms are present on RHS side. So let me write here 2. Hydrogen, there are 2 hydrogen atoms here. Here also there are 2 hydrogen atoms. So this equation is balanced. Now see here, you might remember the activity series which we have learnt in chapter 1 also. Those metals which are placed above in the activity series, that is above the hydrogen, except this lead, they all will displace hydrogen from the dilute acids to form salt and hydrogen gas. You have to remember this point. So, as these metals being reactive than hydrogen, they will displace hydrogen from the acids to form salt and hydrogen gas. Here the salt formed is zinc chloride. And as we know, hydrogen gas is also liberated here. Let's see few more examples here. When magnesium is made to react with dilute H2SO4, that is sulfuric acid, here magnesium displaces hydrogen from the sulfuric acid to form magnesium sulfate salt along with the liberation of hydrogen gas here. This equation is balanced. Now we have to mention the product name also here. This is salt magnesium sulfate. So in general, we say when metals are made to react with the acids, there is a formation of salt and hydrogen gas. You have to remember this general equation so that you can give different examples for these reactions. Let's see how the reaction of metal with acid is carried out. See the example which is given in your textbook here. This is reaction of zinc with dilute sulfuric acid. How it is carried out? We have taken dilute sulfuric acid in this test tube and we have added some zinc granules into this test tube. What we do is we will collect the gas after the reaction which is liberated and we will pass it through the soap solution. Then when the reaction is carried out, there is a formation of zinc sulfate and hydrogen gas. As we have learned, when zinc is made to react with dilute H2SO4, that is dilute sulfuric acid, there is formation of zinc sulfate and hydrogen gas. In this reaction, hydrogen gas is liberated, which is collected in this delivery tube and passed through the soap solution. When this gas burns with a pop sound, then we conclude that the liberated gas is of hydrogen. We call this test as pop test. Hydrogen burns with pop sound when burning candle is brought near to it. This is the test for hydrogen. You have to remember this test. Sometimes it may be asked in your examination also. How do you test the presence of hydrogen gas during the reaction? You have to mention this pop test. Now you have to note one more point here. As we said, when acids react with metals, there is a liberation of hydrogen gas. But there is exception. Hydrogen gas is not evolved when metals react with the nitric acid, that is HNO3. Why? It is due to the reason that nitric acid is strong oxidizing agent. It oxidizes the hydrogen evolved to water. Hydrogen gas is actually formed, but it is oxidized to water by HNO3, so that hydrogen gas is not evolved when metals react with the nitric acid. You have to remember this exception. And again, there is one more exception here. There are two such metals which will liberate hydrogen with very dilute nitric acid. They are manganese and magnesium. Only these two metals, that is magnesium and manganese, these will react with dilute HNO3, very dilute HNO3 to liberate hydrogen gas. You have to remember this exception also. So overall what we have learned here, when metals react with acid, there is a formation of salt and hydrogen gas. These metals which are reactive than hydrogen, they will displace hydrogen from the acids to form salt and hydrogen gas. And dilute nitric acid will not evolve hydrogen gas when it react with metals, as it is a very strong oxidizing agent. It will convert the hydrogen gas liberated to water, that is it oxidizes the hydrogen gas liberated to water. Again, there are two exceptions here, that is magnesium and manganese. They will liberate hydrogen gas when they react with very dilute HNO3. Now let us see, how do bases react with metals. Bases also react with metals to form salt and hydrogen gas. But remember, not all the metals will react with bases. Very few metals, that is amphoteric metals like aluminium and zinc, react with base like sodium hydroxide to form salt and hydrogen gas. These metals, that is aluminium and zinc, which are amphoteric metals which have capacity to react with both acids and bases, they will give salt and hydrogen gas when they react with strong base like sodium hydroxide. Let us write the chemical equation for the reaction of zinc with sodium hydroxide. So the reaction of metal zinc with the base sodium hydroxide, it will give sodium zincate salt, that is Na2ZnO2. Sodium zincate has the formula Na2ZnO2 along with the liberation of hydrogen gas. We have to balance the equation. There are two sodium atoms here. I will write here 2. Now all the atoms are balanced. You have to write the name of the salt, sodium zincate. This example is particularly given in your syllabus. You have to remember this equation. You have to write the balanced chemical equation for the reaction of base with metals. You should mention this specific example. One more metal, aluminium, also react with sodium hydroxide in presence of water to form salt and hydrogen gas. That is, it forms sodium aluminate salt, NaAlO2. The formula for sodium aluminate is NaAlO2, and there is liberation of hydrogen gas. We have to balance the equation. There are 3 hydrogen atoms here. 2 hydrogen atoms are present here. So I will increase the number of hydrogen atoms on RHS. So it has now become 4. But here only there are 3 in number. So again I will write here 2. So that the number of hydrogen atoms will be 4 in number. But the number of sodium atoms are also unbalanced here. So we have to write here 2. Now aluminium atoms are also be balanced by writing 2 here. The number of oxygen atoms are 4. Here there are only 3 oxygen atoms. So I will write here 2. Now the oxygen atoms are also balanced, but the hydrogen atoms still needs to be balanced. Here there are 6 hydrogen atoms. Here there are only 4 hydrogen atoms. So how can we make it 6? Just by writing here 3. Now this equation is balanced. It is important to note down this equation as it is particularly mentioned in your syllabus. It is for your information purpose. Yes, this is sodium aluminate. This is how bases react with metals. The next type of reaction is reaction of acids with metal carbonates and metal hydrogen carbonates. When acids react with metal carbonates and metal hydrogen carbonates, the products that are formed are salt, carbon dioxide and water. Let's see the different examples here to understand the reaction of acid with these compounds. Yes, In general, we can write when metal carbonate or metal hydrogen carbonate react with acid, there is formation of salt, carbon dioxide and water. This is the general form of the equation. Let's take the examples here. For example, sodium carbonate. It is metal carbonate. Sodium is metal and the carbonate of this metal is sodium carbonate. When aqueous solution of sodium carbonate is made to react with the acid, hydrochloric acid, HCl, there is formation of salt, carbon dioxide and water. How does this forms? Let's see here. Here, the double displacement reaction takes place. That is, the cation of this compound will combine with the anion of this compound. In the same way, the anion of this compound will combine with cation of this compound. That is, exchange of ions takes place between these two reactants to form NaCl plus H2CO3. These are the actual products formed here. But this compound being very unstable, it will break down to form water and carbon dioxide. So ultimately, what are the products formed here? This is salt, water and this is carbon dioxide. So whenever metal carbonate will react with acid, there is formation of salt, water and carbon dioxide. So we will write the products as NaCl salt, that is sodium chloride, along with the products water and carbon dioxide. Water and carbon dioxide are common in all the reactions of metal carbonates or metal hydrogen carbonates with acid. But the type of salt formed depends on the reactants which we have taken here. And it is also important to balance the equation here. There are two sodium atoms here. Let me write here 2. Again, the chlorine atoms needs to be balanced. I will write here 2. Now, the number of hydrogen atoms are also same on both the sides. And what about oxygen atoms? They are also same on both the sides. Now, this equation is balanced. Let me take one more example here. That is magnesium carbonate, which is also a metal carbonate. When it reacts with the acid, sulfuric acid, will form the salt magnesium sulfate. This is the salt formed, and along with the formation of water and carbon dioxide. As I said earlier, in all this type of reaction, water and carbon dioxide are common. And the type of salt depends on the reactants which we have taken. That is metal carbonate and acid which we have taken here. Now, this equation is already balanced, so no need to balance it. Then metal hydrogen carbonate also react with acid to form salt, carbon dioxide and water. Let's take the example here. This is sodium hydrogen carbonate, which is metal hydrogen carbonate. Metal hydrogen carbonate reacts with acid, that is dilute hydrochloric acid, to form salt NaCl plus water plus carbon dioxide. So these two are common for all the metal carbonates and metal hydrogen carbonates. The salt formed here is sodium chloride. This equation is also already balanced here. So you have to remember this general equation: when metal carbonates or metal hydrogen carbonates react with acid, there is a formation of salt, carbon dioxide and water. These two are specifically mentioned in your syllabus. You have to note down these reactions. Then here there is evolution of carbon dioxide gas. Again, this gas is colorless. How do we detect this carbon dioxide gas? There is a test called as lime water test for testing carbon dioxide. What we do is, the liberated carbon dioxide is passed through the delivery tube. We will pass it through the lime water. The carbon dioxide gas will turn lime water milky. You can see here the carbon dioxide gas released can be tested by passing it through lime water. Lime water is aqueous solution of calcium hydroxide. When calcium hydroxide reacts with carbon dioxide, there is formation of calcium carbonate precipitate and water. As this is insoluble in water, that solution will appear milky. So in this way we can test whether the liberated gas is carbon dioxide. But what happens when you pass excess of carbon dioxide gas? This milkiness will disappear because it is again due to the chemical reaction that takes place. What happens when excess of carbon dioxide gas is passed through the solution? This calcium carbonate along with this water will react with this carbon dioxide gas which is excess to form HCO3 twice, which is calcium hydrogen carbonate. This is soluble in water, because of which the milkiness will disappear. Here, the question may be asked, how do you test the evolution of carbon dioxide gas? It is by passing the carbon dioxide through lime water. It is the aqueous solution of calcium hydroxide. When you pass carbon dioxide gas through this lime water, there is a reaction which results in the formation of calcium carbonate, which is insoluble in water, because of which this white precipitate of calcium carbonate will make the solution milky. This is calcium carbonate. And again, it may be asked, what happens when excess of carbon dioxide gas is passed? There is a disappearance of milkiness, because this calcium carbonate which is formed along with the water will react with the excess carbon dioxide, resulting in the formation of calcium hydrogen carbonate. This is aqueous solution, means it is soluble in water, because of which the milkiness will disappear. You have to note down these 2 points. See how the reaction between metal carbonate and dilute acid is carried out here. This is a test tube containing dilute hydrochloric acid. We will add metal carbonate, that is sodium carbonate, into this solution. What happens? The reaction takes place between the metal carbonate and the dilute acid to form salt, carbon dioxide and water, as we know. Then we will pass the gas which is liberated during the reaction through this delivery tube to test it, which gas is liberated. And this gas is passed through the lime water, that is calcium hydroxide solution. This is lime water, calcium hydroxide solution. It will turn lime water milky. We will conclude that the liberated gas is carbon dioxide. In this way, we will carry out the reaction. This is all about the reaction of metal carbonates and metal hydrogen carbonates with acids. And note that bases will not react with metal carbonates or metal hydrogen carbonates. So, my dear students, now we are going to see the next chemical property of acids and bases, that is the reaction between acids and bases with each other. There is a special name for this reaction, that is neutralization reaction. How do we define it? Acids and bases will react with each other to form the products salt and water. Here there is formation of products only salt and water. We call such type of reaction as neutralization reaction. In general, we can represent the equation as acid plus base. They react with each other to form products only salt and water. Why do we call this reaction as neutralization reaction? Because base will nullify the effect of acid and acid will nullify the effect of base here. So, we call such reactions as neutralization reaction. You have also come across this neutralization reaction in your grade 7. There you have seen the very famous example, that is the reaction between the acid hydrochloric acid and base sodium hydroxide. Now there is formation of salt, that is sodium chloride, along with the formation of water. See here, what happens actually is there is exchange of ions between these two reactants. So the reaction which takes place here is double displacement reaction, because there is exchange of ions between the reactants. H plus will combine with OH minus to form water, and Cl minus will combine with Na plus to form salt NaCl. So this is double displacement reaction that takes place. Again, you can give many other examples also. Base potassium hydroxide reacts with acid sulfuric acid to form. You can guess the products here. As I said, there is exchange of ions between these two reactants. K plus will combine with SO4 2 minus, that is sulfate ion, to form K2SO4. You should not write KSO4. We know how to write the chemical formula. Let me remind you. We want to write the potassium sulfate chemical formula. Potassium sulfate. Potassium has charge plus 1 and sulfate ion has charge minus 2. So cross multiplication of these two will give you the chemical formula K2SO4. So while writing the products, you should keep in mind to write the correct chemical formula. The product formed here is potassium sulfate, salt, and water is also formed here. Then let's take one more example here. Zinc oxide. It is also base, but it is not soluble in water. It will react with acid HCl to form salt ZnCl2. ZnCl2. Again, this zinc has the charge plus 2 and Cl has the charge minus 1. So, by cross multiplying, we will get the formula ZnCl2. Then there is formation of water. And remember, this zinc oxide is a base which is insoluble in water. And there is a special name for those bases which are soluble in water. For example, sodium hydroxide, potassium hydroxide. These two are soluble in water. They are called as alkalis. Yes, how do we define alkalis then? Bases which are soluble in water are called as alkalis. Examples for alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide. These are soluble in water, so these are called as alkalis. But remember, not all the bases are soluble in water. Like I said, this zinc oxide is a base, but it is not soluble in water, so it is simply called bases. So what conclusion can we draw from this? All alkalis are bases, but not all bases are alkalis. And we can give many examples for insoluble bases like zinc oxide, copper oxide, iron oxide, aluminium oxide, and their respective hydroxide also insoluble. See here, these all are metal oxides, which are bases. These are called as bases because they react with acids to form salt and water. We define bases as those substances which react with acid to form salt and water only. So, it is now clear about the neutralization reaction. And one thing you may observe in the previous type of reaction we have seen, there is a formation of salt and water in the reaction between metal carbonate and acid. But can we call this as neutralization reaction? No, because in neutralization reaction, it is compulsory that only salt and water must be formed. There must not be any other third product there. Here there is formation of carbon dioxide also. So we cannot call it as neutralization reaction. So you have come to know about the neutralization reaction here. The reaction between acid and base to form salt and water only. And the nature of salt need not to be neutral in nature. It might be acidic, basic or neutral. It depends on the strength of acid and base used. We will come to it little later. So right now understand about the neutralization reaction and some of the examples. Let us see the next type of chemical property of acid, that is the reaction of acids with metallic oxides. What's going to happen when acids react with metal oxides? Let's see here. When metal oxides react with acids, they form salt and water. And we know that whenever there is formation of salt and water in a reaction, we call that as neutralization reaction because there is formation of only the products, that is salt and water. This reaction is similar to that of reaction of bases with acids. So we say that metal oxides are basic oxides. When we take the example, you are going to clearly understand the concept here. So let's write the general equation first. When acids react with metallic oxides, we get salt and water. This is a general equation for the reaction of metallic oxides with acids. See here, in the product side, we are going to get only the salt and water. So this reaction is nothing but neutralization reaction that occur between acid and base. We have acid here and this is the metallic oxide, which shows that metallic oxides behave as bases. They are basic in nature, because of which they are going to react with acid to give salt and water. Let's take an example here. Copper oxide is a metallic oxide which is going to react with acid, that is dilute hydrochloric acid. The reaction takes place between these two to form the salt copper chloride and water. This copper oxide is black in color. After the reaction, there is a formation of salt, that is copper 2 chloride or cupric chloride, which is blue-green in color. This is the salt formed. Which is this salt? It is copper 2 chloride. The valency of copper is 2 here. It is also called as cupric chloride. This copper oxide is metal oxide. And as we know, this is hydrochloric acid. So, this metallic oxide, that is copper oxide, react with hydrochloric acid to form the salt copper 2 chloride along with the formation of water. This reaction is similar to the reaction between acid and base to form salt and water. We have acid here. Then it can be concluded that this metallic oxide behave as base. Means copper oxide is basic in nature. We can conclude that metallic oxides are basic in nature because they react with acids to form salt and water. We can take one more example here. Zinc oxide, which is going to react with the uric acid to form salt, zinc sulfate and water. Here also zinc sulfate is the salt form along with the formation of water. H2SO4 is acid. This zinc oxide is metal oxide, that is oxide of metal zinc. As there is formation of salt and water only here, we say this zinc oxide behave as base. So overall we can conclude that metallic oxides are basic in nature. And it is very important to remember this point. Metallic oxides are basic in nature. Now, let us see whether the reaction between the bases and non-metallic oxides is also neutralization reaction. Let us check here. See here, non-metallic oxides react with bases to form salt and water. Again, we get salt and water during the reaction between non-metallic oxides and bases. And this reaction is also similar to that of reaction between acids and bases. So we conclude that non-metallic oxide are acidic oxides. They are acidic in nature. So we can write non-metallic oxide plus base. They undergo reaction to form salt and water. On the product side, we are going to get only the salt and water. So this reaction is also neutralization reaction, because of which we conclude that non-metallic oxides are acidic in nature. Let us take an example here. Consider metallic oxide, that is carbon dioxide, CO2. This is oxide of carbon. Carbon is a non-metal. So this is non-metallic oxide, which is going to react with base, that is calcium hydroxide. Here, the reaction takes place to form calcium carbonate, which is a salt, along with the formation of water here. This is non-metallic oxide. Calcium hydroxide is a base. Calcium carbonate is salt. This is water. Here also there is formation of salt and water only when the reaction takes place between non-metallic oxide and base. So we say that non-metallic oxides are acidic in nature. We conclude non-metallic oxides are acidic in nature. This is the another point to remember. Metallic oxides are basic in nature, non-metallic oxides are acidic in nature. Now, the next topic of our discussion is what happens when acids and bases are dissolved in water. When acids are dissolved in water, they form hydrogen ions, which are nothing but H plus ions. For example, the aqueous solution of hydrochloric acid, it will form H plus ions, that is hydrogen cation, and chloride anion. But remember, these hydrogen cations, they cannot exist alone. They are unstable. So, they always combine with water molecules to form hydronium ions. So, what happens is the H plus ion cannot exist alone. So, they combine with water molecule to form hydronium ion. This is called as hydronium ion. So, we always represent the hydrogen ion as either H plus aqueous or H3O plus ion, that is hydronium ion. And these hydrogen ions are responsible for the acidic properties of these substances. We have come across many acids like hydrochloric acid, sulfuric acid, nitric acid, acetic acid. All molecules contain hydrogen, and when they are dissolved in water, they produces H plus ions. And these H plus ions, that is nothing but when they combine with water, they form hydronium ions. The acidic property is mainly due to the formation of these H plus ions when they are dissolved in water. The hydrogen ions are responsible for their acidic properties. HCl, that is hydrochloric acid, nitric acid, sulfuric acid, they all show acidic character in aqueous solutions because of hydrogen ions produced when dissolved in water. And because of the formation of the ions in water, these all solutions conduct electricity. Not only hydrogen ions are produced in all these acids, but also the respective anions are produced as you see in case of hydrochloric acid. So because of the production of these ions in water, they are capable of conducting electricity. Question may arise then, do all the compounds which contain hydrogen behave as acid? The answer is no. For example, let's take alcohols. Let's take ethanol. It is an alcohol. This is the formula, chemical formula for ethanol. Is it an acid? The answer is no. Even though this compound contains hydrogen, it will not form H plus ions in water. So, ethanol is not considered as an acid here. Same in the case of glucose also. We have the formula C6H12O6. You know, this is molecule of glucose. Even this compound also contains hydrogen. But does it produces hydrogen ion in water? The answer is no. So, these compounds are not considered as acids. Only those compounds which form hydrogen ions in water, they behave as acids. Even you can see in the case of acetic acid. Why it behaves as acid? Because it will form H plus ion when it is dissolved in water. Even though it is weak acid, it will dissociate in water as CH3COO anion, acetate anion and H plus cation. Because of formation of this H plus ion in water, it is an acid. Even though the percentage of dissociation is very less, it is not strong acid, it is weak acid. But due to the formation of this H plus ions in water, this is considered as an acid here. Remember, all these hydrogens are not forming ions here. It is dissociating as given here, that is acetate anion and hydrogen cation. So in this way, solution of compounds like alcohol and glucose, even though they contain hydrogen, they do not show acidic character because they do not produce hydrogen ion in aqueous solution. You have to remember this point. Sometime the question may be asked in your examination that do alcohol behave as acids or why do alcohols do not behave as acids? So our answer is because they do not form hydrogen ions in aqueous solution. We have learned that in case of all the acids, they produce hydrogen ions in water. It is common to all acids. Yes. Then here there is one question. Why does dry HCl gas not change the color of dry litmus paper? We have learned that hydrochloric acid is an acid, but Dry HCl gas is not changing the color of dry litmus paper. What is the reason? Right now we have understood that the acidic character is mainly due to the formation of H plus ions. But observe the question here. It is HCl gas. It is not still dissolved in water. And HCl gas does not contain H plus ions. When it is dissolved in water, it will form ions. Yes, then it will show the acidic character. So simply HCl gas will not change the color of dry litmus paper. Here again they have mentioned dry litmus paper. Even there is no chance of dissociating because we have taken dry litmus paper here, not litmus paper. And if we would have taken wet litmus paper here, then there is chance of dissociating HCl gas into H plus ions. Then it would have shown the acidic character. You have to remember this. Yes, dry HCl gas, you have to write small l here. Dry HCl gas does not change the color of dry litmus paper because an acid shows its acidic properties in solution only due to the formation of hydrogen ions, and in dry condition it is not able to show acidic property due to absence of hydrogen ions. That is, it is not dissociating means splitting into ions. It is not dissociating into ions, so it is not going to show the acidic character. Yes, now this is all clear about what happens when acid is dissolved in water. Now let's see what happens when bases are dissolved in water. When bases are dissolved in water, they produce hydroxyl ions. See here, for example, let's take sodium hydroxide. Aqueous solution of sodium hydroxide will produce sodium cations and hydroxyl anions. And the basic property of the sodium hydroxide is due to the presence of these hydroxyl anions. The acidic property is due to the presence of H plus ions, and basic property is due to the presence of OH minus ions. It is common to the bases which are soluble in water. But remember here, all the bases are not soluble in water. Those bases which are soluble in water, they are called as alkalis. One more example for alkali we can take is potassium hydroxide. The aqueous solution of potassium hydroxide will form potassium cations and hydroxyl anions. These two are alkalis because they are soluble in water to form hydroxyl ions. OH minus ion is called as hydroxyl ion. The example for alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide. These are all alkalis. Magnesium hydroxide is not completely soluble, it is sparingly soluble. And remember that all the bases are not alkalis. We have many examples of bases: copper hydroxide, zinc hydroxide, iron hydroxide, copper oxide, iron oxide, aluminium oxide. All these are bases, but they do not produce hydroxyl ions in water. So they are simply called as bases. But these are alkalis because they are soluble in water to form hydroxyl ions. Then why do we call these as bases then? Because we have the definition for base as bases are those substances which when react with acids form salt and water only. Bases are those substances which react with acids to form salt and water only. All these are bases because they form salt and water only when they react with acids. So these are called as bases. And in your higher classes, you are going to study still more definitions for acids and bases from different perspectives. Right now, understand that acids are those substances which produce H plus ion in water, and bases are those substances which react with acid to form salt and water only because they neutralize the effect of acids to form salt and water. And there is most important point to remember that all these bases, they are not alkalis. Only those bases which are soluble in water, they are called as alkalis. So we have all alkalis are bases, but not all bases are alkalis. So you have to remember that all alkalis are bases, but not all bases are alkalis. So this is all about the acids and bases in a water solution. Now let's talk about dilution of acids and bases. What do we mean by the term dilution? Whenever we mix acidic or basic solution with water, it is called as dilution. We are increasing the quantity of water in a given acidic or basic solution. We call such a process as dilution. But what happens when acids and bases are mixed with water? Mixing an acid or base with water results in decrease in the concentration of hydronium ions and hydroxyl ions per unit volume. For example, if we have taken certain amount of hydrochloric acid solution in a container, obviously it contains H plus ions. Also there will be chloride ions, but we are concentrating here on the acidic property. So let's consider here H plus ions. Suppose we are going to add water to this container. Let's talk about the process of dilution a little bit later. First understand the concept here. Now we have added water to this container. What happens? Once we add water to this container, you can see here per unit volume, the concentration, the amount of hydronium ions have decreased. Initially, for this amount of solution, I was getting 2 ions. Here, I am getting only 1 ion, which shows that there is decrease in the concentration of the ions per unit volume. Of course, we will be having millions of ions in a small quantity of acid also. We are not bothering about the number here. We are concerned about the concept. So once I have added water to this solution, I have got decrease in the concentration of the hydronium ions per unit volume. Initially, for this amount of acid, I was getting 6 to 7 hydronium ions here. For the same quantity of solution here, I am getting hardly only 2 ions here. This shows that there is decrease in the concentration of hydronium ions per unit volume. It is in case of acidic solution. And this is same in case of basic solution also. It will also cause the decrease in the concentration of hydroxyl ions per unit volume once we dilute the acidic or basic solution. So this is what happens whenever we mix an acid or base with water. And remember that whenever we dissolve acid or base in water, it is highly exothermic process, means large amount of heat is produced. The process of dissolving an acid or base in water, it is a highly exothermic one, means it releases large amount of heat. So we will always take care whenever we mix concentrated strong acids like nitric acid or sulfuric acid with water, and it is obvious that all the acids should be carefully diluted. What is the process for diluting the acid or base? The acid must always be added slowly to water with constant stirring. This is important. We should never add water to a acid or base, because as we have learned that this process is exothermic. Whenever you add water to the acid, that is concentrated acid, large amount of heat that is produced, it will cause the mixture to splash out, and even it will cause burns. Sometimes it will also cause the breakage of the containers in which we are diluting. So we will always add acid or base to the water with constant stirring. The heat released should not be concentrated at a single point. Otherwise, it will cause the mixture to splash out. Of course, it is also exothermic one whenever you add acid or base to a water. But what happens is the heat that is liberated is absorbed by the water, because water is a good coolant as we know. So it will not concentrate the heat. It will not cause the splashing out of the mixture when you slowly add acid or base to the water. That too with constant stirring. The heat liberated must be spread out through the water so that it can absorb that heat. Heat is not concentrated at a single point. This is the process how do we dilute the acids and bases. Along with this, we will come across the terms like dilute and concentrated acids. So dilute acid is an acid which contains a greater concentration of water in it than the acid. Whereas in case of concentrated acid, it is having very large amount of acid than water in the solution. In case of dilute acid, we have less number of available ions per unit volume. Whereas in case of concentrated acid, we have large amount of ions available per unit volume. This is the difference between dilute and concentrated acid.